Alright, so as promised, I would do a video for ray diagrams. So here we are with a converging lens. It says it up here. This is another way, a symbol for doing it. I didn't do this in class, but we could just draw it in if we're not sure. So there's a converging lens. So the first rule is parallel to the principal focus. So here we are, parallel to the principal focus, or the principal axis, sorry. That's the principal axis right here. Goes through the optic center and gets refracted through the primary focal point. And you draw it nice and long because you don't know where that image is going to come through. Then, the one that is the easiest to do, if you can do it, goes straight through the optical center. So no refraction occurs. That's because the angle of incidence is 0. You go through, there's that. So we always do it from the top. So where they cross is actually the top of our image. The base of our image comes through along that principal axis. All right, so if I want to do the last one for fun, it goes through the secondary focal point. This is like the opposite of the first one. Goes through this point right here, which is the same distance from the lens, just on the same side, and then gets refracted parallel to the principal axis. And if I do a good job, I should have all three crossing at the same point. Yeah, pretty much I do. So that forms the top of the image. So let me just go through that. So from the top of the object, goes through the secondary focal point, or we call that, in class we called it with the prime, gets refracted parallel to the principal axis. The first one I did went parallel to the principal axis. When it hits the lens, it gets refracted through that primary focal point. And the one in this purpley pink went straight through the optical center. And this forms my image. Now if I look at the image compared to the object is over here. It's inverted, so we call it salt. I can see it's smaller. S stands for size. Attitude, it's inverted or upside down, which means it's flipped. Location, it's just beyond the focal point. So if we can imagine 2 times the focal length, so it's between the focal length and 2 times the focal length, between F and 2F. And then the last is the type. It is real. If you could imagine, you could put a screen here, so I could project that image onto a screen, so it is real. The other thing we'd say, it's on the other side of the object with the lens in between it, so that also says it's real. Okay, so that's for an object far, far, far away from the lens, beyond 2F. All right, so let's do a more difficult one. Why don't we do on F? The rule's the same, it's just finding the image. Sometimes we have to go backwards because we don't realize that light changes direction. So that first one, parallel to the principal axis, and then refracted through the focal point, the primary focal point. Draw it nice and long, because you never know where that image is going to appear. Up here, and then we'll do that one that goes straight through. There we go. Let's go straight through. And since I'm on F, I cannot do the other ray. So I can see these are parallel. They will never cross. So when I do salt, size, no image. Okay, for any of those. There's actually no image at all. Okay, so there's no properties to assess. All right, so what about just inside F? So do that first one. Parallel to the principal axis, gets refracted through the primary focus. All right, so that goes through here. Our eye is somewhere here. Oops, you guys can't see that, sorry. I'll push it up. There we go, here's our eye. The rays are coming to our eye. Let's do through the optical center. All right, and you can see they're actually getting wider, so they're not going to cross. But if our eye is here, our eye will need to, it follows and thinks the ray of light is coming from somewhere back here. And I can see if I drew this one, maybe I didn't draw it long enough. Let's see. Our eye doesn't realize that the light bends. I can see I have to do it a little bit longer. Do this one a little bit longer. I'm doing dotted lines because that light, the rays aren't really there, but our eye thinks they're coming from there, and so they cross about here. So here would be my image. So if I did salt for my image here, size, it would be bigger. Attitude would be upright. Location would be beyond 2F primed, and type would be virtual because it is on the same side as the object. This is the object, this is the image, and if you think about it, if the screen is here, you can't really project it on there. Now what would this be? This would be a magnifying lens. So you're holding up a magnifying lens, it looks bigger and upright. All right, so there are 3 examples of a converging lens ray diagrams. 1, 2, and the first one, there we are. Right there. So you can pause, see what you need to look at, okay?